Hi folks, welcome to my course on Ansible with AWS. So let us discuss on few of the tasks that Ansible shines in. The first important task is provisioning infrastructure. So this could mean creating a VPC network, creating a Lambda function, a virtual machine, or even creating an S3 bucket with a static website. The other thing that Ansible is good at is deployment. So this could mean deploying an Apache or an Nginx web server as well as applications on top of those web servers. So Ansible is really good at doing that as well. And the third task that Ansible is really good at doing is it can combine with tools like Jenkins to create a CI/CD pipeline. So these are the three main important tasks that Ansible does. That is provision infrastructure, deploy applications, as well as combine with other tools to form a CI/CD pipeline. So I'll see you in the next lecture where we talk about the architecture of Ansible. So now let's look at the architecture of Ansible. So Ansible consists of a control machine. So this control machine is basically where Ansible is deployed or installed. And this control machine can only be a Linux machine. Currently, the control machine cannot be Windows and it does not support Windows. And it is always known as host, local host. So your control machine would always be referred to as a local host. In our following examples, we'll be running our control machine in the Cloud Shell, that is the AWS Cloud Shell. Apart from the control machine, there are three important files that I would like you guys to be familiar with early on itself. The first one is the configuration file. So that contains all configuration related information. And the second important file is the inventory file. So the inventory file is again a file that will contain all information about all the EC2 machines that have been provisioned by Ansible. And then comes the most important file called as the playbook file. So this playbook file is something that I would like you to be familiar with early on itself. It's basically a YAML configuration file. And this playbook file is fed to your Ansible. And Ansible, based on whatever tasks are mentioned in the playbook, would create architecture or infrastructure. So here, once I've run my playbook, you can see that I have deployed the following infrastructure. I have deployed two EC2 machines, and each of them have a separate host called Apache and Nginx. And I've also installed a Lambda and an S3 bucket. Now, these EC2 machines that I have deployed will have its information available in the inventory file that I had specified earlier. And apart from that, the other thing I can do is I can also have new playbooks created. And these playbooks can SSH to those particular new EC2 machines, and they can run scripts on those particular EC2 machines as well. And this is how deployment of applications happen in these EC2 machines. So that is the second part of deploying applications. So I hope this was a useful lecture, and just make sure that you remember all these files. That is the playbook, which is arguably the most important file, and also the inventory file and the ansible.config file, which we will make use of in the upcoming lectures. So I'll see you there. So now let's discuss how you can install Ansible on your local machine. So to install Ansible, you need Python running on your local machine. After you've installed Python, you can install pip. Pip is basically the package manager available in Python. And then you need to install Boto. So Boto is basically another library that acts as an interface between Python and AWS. And after you install both of these, you can just install Ansible using the command as shown in the screen. So this is one way of deploying, or this is one way of installing Ansible. There are multiple other ways as well based on the operating systems you have. But one important thing to remember is your control machine, as I said previously, can only run on Linux. I will give you a link on how you can install Ansible based on your operating system. It will be in the description and the resource section, and you can just deploy based on the operating. So let's open our Cloud Shell. To open your Cloud Shell, you can go to your AWS console and just click on this icon. And once you have installed Ansible, you can just do an Ansible / version, and it should return an output like this. And if it returns an output like this, that means you have successfully installed Ansible. So I'll see you in the next chapter. Now let's talk about YAML. Now, because your playbook is going to be written in YAML, it is very important for you to understand YAML and how it is written. I mean, YAML not only comes in handy if you're writing Ansible, but it's also used in other configuration languages and in other configuration scripts. For example, if you're using CloudFormation in AWS or in any other cloud related tools like even your Google deployment manager uses YAML. So it's very important for you to understand YAML. Even if you do not care about Ansible, you still would be using YAML somewhere or the other. Now, YAML consists of three main building blocks. Now, they include scalar, list, and directory. So what are scalars? Scalars are basically just ordinary key value pairs. And the values for these key value pairs can be either a number, a string, or a boolean. Now here are a few examples of scalars and how they look like. Now let's look at lists. So lists are basically a collection of elements. So the syntax for the list looks something like this. So every element of the list is indented and starts with a dash and a space. So here is a list of fruits. So you can see that the list includes apples, oranges, strawberries, and mangoes. Now the third building block of YAML is called as a directory, and directory is a collection of key value pairs. You could also call it to be a collection of scalar. And for example, here is an example of a dictionary is given below. So here is an employee record. So here the name is Martin, and the name and Martin has the following collection of key value pairs, that is the name, the job, and the skill. Now combining your three building blocks, that is the directory, the list, and the scalar, you create a YAML file. Now let's create a few YAML files and let's see how it works. So let me show you a few examples of YAML. So I'm using my Visual Studio Code and I also have a plugin. So I have a plugin called YAML sort to just validate my particular YAML. Of course, you can do it online as well. And I'll show you how it can be done online. So let's first create a YAML file. So to create a YAML file, you can just type new dot. You can either type YAML, YAML or YML. Both are valid syntax. So let me start by giving you a few examples of scalars. So a scalar would be something like this. Name, you can have a department, let's say account, a salary. So here you can mention this as a number. So these are all scalars, and you can also have boolean. So let's say whether if this particular person is a permanent or not, permanent employee or not. So I can just say false. So this is a set of scalar values. Now, after we created the scalar, let's create a list of scalar values. So let us assume that this particular individual is a worker or an employee in an organization. So what we'll do is we'll create a list of workers who are working in a particular organization. So to do that, all I need to do is I just need to indent this and give a dash. So once I've done that, I need to make sure that all the other values within the list are indented as well. So here I've created one particular item in a list. So what I'll do is I'll just copy this and I'll paste it. So here I'll just give this another name and I'll just say instead of account, I'll just say sales. And his salary would be a little higher. And this guy is permanent. So this is true. So here I have currently created a list of two individuals who are working in an organization. So this is an example of list. So let's look at Terry. So Terry is working in the sales department. So he has got a few targets that he need to fulfill. So let's add a target as a dictionary in this particular item. So what I'll do is I'll add a target. So this is an example of a dictionary. So in this, I'll just say quarter 1. The target for Terry is, let's say, $1,000, and similarly for quarter 2 his target is 2,000, and for quarter 3 it's 4,000. Here another important thing to note is you have to, after the colon, you have to give a space, else it becomes incorrect. So that's one thing that you should always remember. And let's take quarter 4 as 5,000. Okay, so now we have two items in a list, and item 2, that is Terry, he has got a dictionary in his particular item, that is target, and this particular target consists of 4 key value pairs, that is quarter 1, quarter 2, quarter 3, and quarter 4. So this is an example of a dictionary here, and here this is an example of a list. So this list, like I said, contains 2 items. And every individual key value pairs here, they're an example of scalar. Okay, so now that this particular list has two items, let's add another item to this particular list, but let's add it without the dash and let's see what happens. So I'll just add a name without the dash and let's call this guy as Gary. You can see that this particular name throws an error. So it's important that you always add a dash if you want to include it in that list. So now it's fine. So this is how you create YAML files. You just need to remember those three basic building blocks. And once you are aware of those three building blocks and how they work, then you can create any YAML that you like. So that's it for this particular section. So I will see you in the next. I have also a few set of assignments that I would like you guys to do. So once you've done that, then I'm sure that you would have mastered YAML and you can tackle any YAML document that you wish. So I'll see you in the next section. So now that you know a bit about YAML, let's discuss the anatomy of a playbook. A playbook can be defined as a list of plays. So here in this particular playbook, you can see that there are two plays. The play one is to create a bunch of instances in AWS, and play two is to create an S3 bucket in AWS. Now each play will also have a host. So that host defines where that particular play will be executed. So here in this particular example, both the hosts are local host. That means that both the plays would be executed on the local host itself. And then comes the list of tasks that has to be executed for each play. So here in this particular example, you can see that there are two tasks for play one, and each of these tasks will basically just execute an AWS EC2 command. So this is basically the AWS CLI command to create an instance. So here in this example, it will create two instances, one of type T2 micro and the other of type T3 micro. Now, of course, these things will be discussed in details in the upcoming section. So this is just to show you how a playbook looks like. And similarly, if you look at the task for play 2, you can see that that particular task is another AWS CLI command just to create an S3 bucket. So that's how the anatomy of a playbook looks like. So again, just to reiterate, each playbook is just a list of plays, and each play also has a host that defines where that particular play has to be executed, as well as a list of tasks. So just remember that it's a list of tasks, and there will be a dash followed by the command that you need to execute. So that's it for the anatomy of a playbook. I'll see you in the next section. So in this particular chapter, we'll discuss about variables. But before discussing about variables, let me show you a brief overview of a very simple playbook. So this particular playbook has one single play, and the name of this play is variable example. It has a host of local hosts. That means that this particular playbook will run on the local host itself. And then we encounter a fetch variable. So this particular variable is named test, and it has a value of ABC. And then comes the task, and here we encounter a fetch module. So tasks are made up of a list of modules. So this is the fetch module that you'll encounter, and it's called as the debug module. And all that the debug module does is it just outputs a message, and the message that it will output is basically just the test. That is the variable that we have declared. So whenever you see these two curly braces, you are encountering something called as Jinja. So let us discuss what Jinja is before we proceed and talk about variables. So now let's talk about Jinja. Jinja is basically a Python template language, and it enables you to create dynamic expressions, and it enables you to access variables. So in our previous chapter, we had seen a playbook that looked something like this. It had a variable, the variable name was test, and it had a value of ABC. And then we used a module called debug to output that particular value. So whenever we place this particular test within a Jinja expression, then the value that we get is basically the value of that particular variable. So here is how the output of a particular Jinja expression would look like based on the input. Now again, if the input is a variable, the output is the value of that particular variable. If the input is a string, the output is the same string again. And if it's a number, let's say 1 plus 1, then the output would be 2. And again, if it's a list or a dictionary, the output would be again the list and the dictionary itself. So here the important thing again is if your Jinja expression has a variable within it, then the output is the value of that variable. So here is my playbook again, and again the value of the variable test is ABC, and I'm just outputting the variable test using a Jinja expression. That is, I'm encapsulating it with a Jinja expression. So let's run this particular playbook. Now to run this particular playbook, I need to use the command Ansible-playbook. And I just need to mention the name of the YAML file, which is main.yaml. So this is the first playbook that you have executed in this course. So make sure that you remember this particular command. So you can see the output that you get is ABC, that is the value of your variable test. So let's make a few changes to this particular. So now instead of test, what I'll do is I'll just convert this test into a string as well. So to do that, I just need to encapsulate it with a single quote. So let me just do that. So here I've encapsulated it with a single quote. And if I run this now, the value should not be ABC, but it should be test. So here you can see that the value is test. Now let's use numbers rather than strings. So again, let me change this and I'll just do a 1 plus 1 and let me run this again. So if I run this again, it should give me 1 plus 1 equal to 2. So you can see that the value here is 2. So this is how you use Ginger expressions in your code. So it's very important that you know about Ginger expressions. And just remember that whenever you see a double curly braces in your playbook, that means it is just a Ginger expression. So I'll see you in the next chapter. So Ginger expressions can also have something called as Ginger filters within them. Now these filters are separated from the variables by the pipe symbol. Now here is an example of a Ginger filter. So here I have a list of elements that is 1, 2, 3, 4, 5, and I just want to select the odd one out of them. So what I'll do is I will have a pipe separator and then this particular select odd is a Ginger filter. So when I output this particular Ansible playbook, the output that I get is 135. That is, it'll just sort out the odd ones from that particular list. Now here are a list of all the filters that are available. Of course, there is a link as well, which I will provide in the description below. So let's have a look at a few examples of this. The first filter that I'll show you is a filter called sum. So that is this particular filter. So what this will do is it will just sum up all the elements in a list. So what I'll do is I'll just add 1, 2, 3, 4, 5. And then the pipe symbol, and then I'll just do a sum. And let's run this particular. So you can see the sum is 15. So this is basically the sum of all the elements in that list. So let's do one more. Let's do a sort. So what I'll do is I'll go back to my code and I will add a few more variables in this particular list. So here I have an unsorted list. So let's do a sort instead of a sum here. And let's run this particular playbook. So here you can see that that particular list has been sorted. So these are a few ways in which you can use your filters. Now, of course, as we go further down this particular course, you'll see a few useful uses of filters. So I will see you in the next lecture. So in this particular section, let's talk about the kinds of variables that are available in Ansible. They include the simple, the list, and the dictionary variable. And it also includes something called as registering variables. That's something that I'll talk to you about in a later section. So the simple, the list, and the dictionary correspond to the basic building blocks of YAML. So the basic building blocks of YAML include the scalar, the list, and the dictionary. So the syntax for those and these variables are basically the same. So let's start by talking about the simple variables. So we had seen an example of the simple variable in our previous section where we talked about Ginger. So here the variable name is test and the value for that particular variable test is ABC. And if you do an Ansible playbook main.yaml, you can see that the output you get is ABC. That is the value of the variable test. So this is how you can define a simple variable in your playbook. You can also call your simple variables dynamically. So here is an example of a playbook. The playbook has just a message test, but that particular variable test is not defined in the playbook. You can define this playbook while you are executing this playbook. So to do that, you can just call the Ansible playbook YAML file, and then you can append it with an extra vars keyword, and within that you can add the value for that particular variable. So here the variable has a value of test equal to ABC, and if you output that particular playbook, you can see that the message you get is also ABC. So this is how you can define your simple variables dynamically. Now you can also use an external file to store your variables. So here I have an external file, and this external file has a key value called name Rohit. Now if I wanted my playbook to use this particular file, I have to use a where's underscore files, and here I have to define the path of that particular file. And just like you would call any other variable, you can just call the variable name that you have defined in your particular file. And the output that you get is Rohit, that is the value for that particular variable. So now let's talk about the list variables. Here you can define a list within the playbook itself. So for example, in this particular diagram, there is a particular variable called region, and it has a list of values. So that is the US, Europe, and Asia. And as an output, I'm just displaying the first particular element of that particular variable region, that is US. So that's about it. When you run this particular playbook, you'll get the value US. So this is how you define your list in a playbook. Now you can also define a file. Now you can also define a list in a file and call it dynamically. So here I have a file called my external variable, and it has a list of values in them. So the list includes Northeast, Southeast, and Midwest. Now let's call our playbook. Our playbook is just nothing. There are no variables declared in our playbook. And the only module that it has is the debug. And the debug is just outputting out the first element of that particular my external var. So when you're calling this particular playbook, you just need to add the extra vars, and that extra vars has to point to that file that you had created. And that's about it. The output that you get would be the first element of the my external file variable, the my external variable file. So that is the Northeast. Now you can also define a list in a file and call it in the playbook. So again, you have your external variables. And here the only difference is that you're calling that particular file within the playbook itself as where's underscore file. And then you have to give the particular path of that particular file that you have created. And the output would be similar. You'll just get Northeast. So the difference between this method and the previous one is that in this particular method, the file is being called within the playbook itself, whereas in the previous example, the file was being called when you were executing that particular playbook, and that was being called dynamically. So that is the main difference between this and the previous method. Now let's look at the dictionary variable. Now the dictionary variable and the list variable follow the same pattern. You can define the dictionary variable within your playbook itself, or you can define them within a file. So now let's have a look at this particular example. So here I've created a file, and this file has got a dictionary. And if you look at the playbook has no reference to this particular file. So the reference is given when you're calling this particular playbook. So here you have to call the Ansible playbook, and you have to give an extra parameter called extra vars, like you had done previously for the list. And this extra vars has to point to this particular file. And then once you run this particular playbook, you'll get the appropriate output. So the output is basically AMI of US East 1 HVM64, that is US East 1 HVM64. So this is the value that you get as the output. Now similarly, you can also call your particular file within the playbook itself. So here within the vars underscore files, I have given a path to this particular file, and that's about it. You can just call your Ansible playbook without having to give a dynamic reference to this file, and you'll get the same output. So that is how you define your dictionary, your lists, and your variables. So I'll see you in the next chapter. So in this particular chapter, you'll see how you can connect your control machine with AWS. So to do that, you just need to create a user first. So again, I'm in my AWS console. I'm in my IAM, and here I'll create a user. So I'll click on add users. So I'll call this user as Ansible user. I will just give this user programmatic access. Click on next. And here I'll give this particular user admin access because I want this particular user to have access for everything. Now, if you're running it in a production environment, just make sure to give that particular user just enough access and not more. Click on next, next, and create user. So once you've created your user, you get the access key ID and the secret access key. So all that you need to do is you just need to configure these two values. So now let's go back to our Cloud Shell. Now to configure those two variables, all that you need to do is if you have CLI present, you just need to do an AWS configure. And here you need to paste the access key ID and the secret access key that you got here. And that's about it. So once you've done that, you have configured your control machine with your AWS account. Now, if you do not have your CLI present, that is, if you do not have your AWS present on your control machine, you can also export those two variables. To do that, let's go back to our authentication page in the Ansible documentation. And here, all that you need to do is you just need to export these two variables. So I'll just export this variable, and this particular key ID corresponds to this particular value. And similarly, this particular secret access key corresponds to this value. So all that I need to do is I just need to export these two values. So I'll just copy this and I'll paste it. And that's about it. So there are two ways in which you can configure. If you have your CLI present, you can just use your AWS configure. If you do not have your CLI present, then you need to export these two variables. So it's a very basic and a very simple way to connect your control machine to your AWS account. So I'll see you in the next lecture. So now let's talk about modules. Modules are basically discrete units of code that can be used either from your command line or in a playbook task. So in our previous example, we had seen how we could use the debug module to output a particular variable onto the screen. Now there are other such very basic modules that are available in Ansible. Another example of a module. Now, another very common module is called the command module. So this command module will run the AWS EC2 instance, and the output of this particular command you can see in a register called AWS. So that's an example that I'll show you in the upcoming section. Now, to get more information about your particular module, you can run the Ansible -doc followed by the module name that you want to check. Now here is an example of how you can see the documentation for the command module. So you can just do an Ansible -doc followed by command, and you'll get all information about that particular module, the arguments that you need to pass, etc. One important thing to note is that these modules are all written in Python. So a little knowledge about Python can help you understand better Ansible, though it's actually not mandatory to know Python, but it certainly does help. Now you can run your module in two ways. You can run it within a playbook or you can run it as an ad hoc command. Now if you want to run it as a playbook, here is a very common example. So here I have the command module, and in this particular command module, I'm just running the AWS EC2 run instance command. And this particular module here is being run within a playbook. You can also run the same command as an ad hoc command. So here you just need to give the name of your particular module. So the module here is command and the arguments for that particular module. So here is the argument for that particular module. It's basically the same argument that you see over here. And both these commands, that is running it through the playbook or ad hoc command, would give the same output. Another important thing to note is that the host here is localhost. So that means that this particular playbook would be executed on the localhost. So similarly, if you want to run it as an ad hoc command, you have to give the localhost within that particular command itself. So if it's not the localhost, then you have to mention on which particular host you want to run this particular command. So that's it for this particular section. So I'll see you in the next. So how do you find the right modules in Ansible? You can actually divide your Ansible modules into two halves. You can divide it into core modules and the modules that you'll find in galaxy.ansible.com. So galaxy.ansible.com is basically the place where you'll find everything from your modules to your roles to your playbooks. So that is basically a repository that Ansible has. Whereas the core modules are basically modules that are already present when you download Ansible. So let's look at where you can find your core modules, and let's also run a few examples of core modules. So here I'm in my command prompt. So to get the list of all the core modules that are there in Ansible, you can do an Ansible version, and then the output that you get would have an Ansible Python module location. So you can copy this particular path, and in that particular path, you will find a folder called modules. So you can just go to that particular modules path. And if you do an ls, you can find all the core modules that are available for you to use. So let's use a few of these core modules. So now let's use some of the most commonly used core modules. So let's start by running the command module. So we'll be running this as an ad hoc command and not within a playbook. So again, to run your particular core module as an ad hoc command, you do an Ansible Then where do you want to run this particular command? So I want to run it on the local host itself. So I'll just call it as localhost. And then the module that I want to run, which is the command module. And then the parameter for this command module. So for that, you can just do a -a and you can give a parameter. So I'll just start by giving an ls-lt. So you can see that you get an output. So here is basically the ls command within that same particular path. So now let's do something different. So let's run an AWS CLI command. So I'll run an AWS S3 ls. So this should give me all the buckets that are currently set up in my AWS account. So this gives me all the S3 buckets that I currently have in my AWS account. So now let's run the ping command. The ping command is very easy. It'll just ping that particular host that you have specified. So again, it's Ansible. The host that I have specified is again localhost. And then the name of the module, which is just ping. So here I do not need to add any arguments. So I'll just run it like this. So you can see that the ping was successful. Now let's run another command. So let's run the copy command. So first thing I'll do is I will see how this particular copy command works. So to do that, I'll just do an Ansible doc and I'll just write the name of the command or the module, which is copy. So the copy command copies a file from the local or a remote machine to a location on the remote machine. So because I have not set up any remote machine currently, this is something that I'll teach you in the upcoming lesson. So let's just leave this particular module for the time being. So that's how you actually use your core modules. You should always look up the help file and see what that particular core module does. And you'll get a better understanding. So I hope this was a useful lecture. And what you can do as an exercise is these particular commands that I have run as ad hoc, you can copy them and run it in a playbook as well. So once you've done that, you'll have a better understanding of how playbooks work and how your core module works. So I'll see you in the next chapter. So in our previous module, we had seen how you can run a module using the ad hoc command. So we are going to do the same thing, but instead of using the ad hoc command, we'll use the playbook to do the same. So here I have a very common playbook, and this particular playbook runs on the local host, and it has a list of tasks. And each task corresponds to a particular module. So here you can see that there are two modules. The first is the command module, and the second is the debug module. So this particular command module will just do an LSLT on the current working path, and then the particular output of this command will be stored in the output register. So this is the first time you've encountered the register variable, and you can get the value of this particular output variable using the Ginger expression as you see here. So let's run this particular command, or should I say, let's run this particular playbook and let's see what the output looks like. Again, to run your playbook, you just need to call the Ansible playbook, and the name of my playbook is main1.yaml module that you ran. So here you can see the output of the command module that you ran, that is the lslt. So that's it for this particular lecture. I'll see you in the next. Now, apart from the core modules, Ansible also provides custom modules as well as community modules that you can use in your playbook. So let's look at how you can find your particular module. So to do that, you can just log into your galaxy.com. So this is basically the repository that Ansible has. So in that, you can go to the second tab here. And the first thing we'll search for is basically the modules that are provided by Amazon. So for that, you can go and just search Amazon. So here the first output that you get is basically the modules that is provided by Amazon itself. So you can just open this and you can just click on content and just search for the module. So if you just untick the others, so you can see that these are the modules that are provided by Amazon itself. So in our upcoming lectures, we'll be using most of these modules. So this is the modules that is provided by AWS. So as you can see that this has a very limited set of modules. So for example, if you want to create a Lambda, there is no module that will help you in creating a Lambda. So for that, there is also a community that creates modules for Amazon. So again, if you go back to your search, you can just type AWS. So here you can see that there is a community, and this particular community also creates modules. So let's just open this AWS community module. So if you again go to your content, and if you open the modules, you can just untick the others. You can see that there is a large variety that is available to you. So you can always use this. So for example, if you want to create a Lambda, there is a module available for you to create Lambdas here. Now, of course, these modules I'll be using in the upcoming lecture. So this is just an introduction for you to figure out where you can actually find these modules. So like I said, again, there are two sets. There is the one that is developed by Amazon itself, and then there is the community module. And you'll find a larger variety of modules available in the community section. So I'll see you in the next chapters where I'll use these particular modules in giving demos. So I'll see you there. Again, I'm back in my galaxy.ansible.com. So let's go back to our second link here. And here I'll type AWS. So let's use the modules that are provided by Amazon first. So I'll just click on this particular link. I'll open this. Now to download these modules in your local, you need to run this particular command. So what I'll do is I'll just copy this command and I'll run it in my Cloud Shell. So I'll just paste it. So as you can see that I already have it installed. So the first thing you would want to know is where are these modules installed? So the best way to actually figure that out is just find one of the modules within this particular collection. So I'll just, okay, let's imagine that I want to find the path of this particular module. So I'll just copy this. I'll go back to my Cloud Shell and I'll do the Ansible doc again. And I'll paste that particular module. And it should provide me the path where this particular module is. So you can see that that particular module is within this particular path. And it gives me all the other information that is required to run this particular module. So that is how you will find the path for your particular module. So let's use one of these modules in the upcoming section. Okay, the first and the most simplest example that we'll do is we'll create an instance using the module that we've downloaded. So the module that we would be using is basically the EC2 module. So to get more information about this particular module, you can again do an Ansible-doc and then just type EC2. And you'll get all the information about this particular module. Now you can get the same information using a URL as well. So this is the URL that you use. I will link this particular URL in the description below. So this particular URL has all the module information that you need. So what we'll be doing is we'll be using this particular module. So it's called the EC2 module. So what this particular module will do is it creates, terminates, starts or stops an instance in EC2. Of course, this documentation that you see over here and this documentation is basically the same. So it depends on your convenience how you would want to see it. You can either use the Ansible-/doc or you could see that same information in this URL as well. So let's create our first instance. So I'll create a new file. I'll just call this create instance and it'll be a YAML file. So let's create a playbook. So again, like I said, a playbook is a list of plays. So it has to start with a dash followed by a name. So I like giving the name convention so that you can give a description for your particular play. So I'll just call this as creator instance. And then the second thing is the host. So the host would be basically local host because you're running it on the local host itself. So I'll give you examples where the host is not local host. That'll be in the upcoming lessons. So okay, so you're done with your name and your host. Now you need to give the task. So as I said before, your play will contain a list of tasks. So let's start creating these tasks. So the first and the only task that we need is basically the EC2 module. So again, I'll give a name for this particular task. I'll just call this as module to create an instance. And now we have to give the name of our module. So the name of our module is EC2. And now we have to give the parameters for this particular module. So let's go back to our documentation. So you don't need to give the public and the access key because that's already done using the AWS configure. So the important parameters that you need to give are basically the image. So the image is a required field if you are creating the instance. So I'll just copy this image. And I need to give an image ID. So let's go back to our AWS console and let's get an image ID. So I go to my EC2. Here underneath images, I'll just click on AMI, public images. So what I need is an Amazon 2 Linux version. So let's just Amazon 2. And let's add a few more filters. So the architecture should be an 86 and the owner should be Amazon itself, Amazon images. And what I need is a latest image. So I'll just click on creation date. And after, let's say the beginning of this particular month. So I click set. So I got the AMI that I need. So this is basically a Amazon Linux version. So I'll just copy this and I'll paste it here. Okay, so you have your image. So the next thing that we need is the instance type. So what you need is what particular instance type you want your machine to be. So let's copy this instance type as well. And this will basically be a T2 micro. And these are the only parameters that you need to create an instance. Everything else is basically a default. So if you're creating a particular EC2, then you need an image and you also need an instance type. So let's run this particular playbook. Again, I will just run the Ansible playbook create instance. And you can see that it has been created. So let's go back to our EC2 dashboard. So this is how we create the instance. So you can see that my instance is created and it's currently initializing. If you go through the other parameters, you can see that it's created on the default VPN. So I will see you in the next lecture where we can add a little more complexity to this particular piece of code. So I'll see you there. So now let's look at a few more examples of creating instances using our EC2 module. So here is an example of an EC2 module that has an ID. So what this ID does is that it makes this entire module idempotent. So this is a very distinct functionality of this EC2 module. What idempotent is, I will tell you once I run this particular script. Apart from that, the image, the instance is basically the same. And there is a count of 2. So what that means is that this particular module will create 2 instances. And the state present means that this particular state will be created. And we've also added an instance tag and we've added a wait. So what this wait will do is it will wait for the instance to get created and only then will it exit this particular script. So let's run this particular module as well. So again, to run the module, I'll just do an Ansible playbook and just the name of this particular script. So let me just copy this. So as you can see that this particular task will only exit after that particular instance has been created. So let's just wait for a few more seconds. Okay, now if you look at the output, you can see that there were 2 tasks. The first was the gathering facts and the other one was the main task of creating the module. And this has changed once. So the gather facts is something that I'll explain later on. It's not something very important for you to know right now. If you look at the main task, that is the task of creating those two instances, it has changed. You can see that change is equal to 1. So now let's go back and check our console, our AWS console, and let's see whether those instances have been created. So I go back to my services. I'll just open my EC2 console. So you can see there are two instances running. So these are the instances that we've just created. So you can see that it's still in an initializing stage. Now, what if I run the same script again? What would happen? Now, ideally, it would have created two more instances. Now, because I've added that particular ID has made that particular module idempotent. So what that means is even if I run the script again, it will not create any new instances. It'll just exit gracefully. So let's see what happens if we run it again. And you can see that this time it did not have a change equal to 1. It just exited this particular task without creating any new instances. So that's how idempotence works in the EC2 module. So you have to put the ID and you have to give a value for that ID to make the idempotence work. So idempotence is a very important concept where if by mistake you run the same script again, you do not want new instances to get created. So to avoid something like that, you should add IDs to your particular EC2 module. So I have created another task, and this particular task will use the same EC2 module. So the only difference here is I am just doing a state equal to stop. So hopefully this particular task should stop the instances that we had created in the previous task. And you also need to give the instance tags or the instance ID. So I'll just give the instance tag. So the instance tag again is just web server, and I'll also do a wait yes. So let's run this particular module and let's see what happens. Okay, so the playbook has finished running. So if you look at this particular output, you can see that the create has not run because it's already created an instance. However, the module to delete the instance has changed. And let's go and look at our instances and let's see whether it's in a running state. So if I just refresh this, you can see that there's nothing in a running state. So if I just remove that, so if I just remove that particular setting, you can see that those two states are currently in a stop state. So this is how you run the EC2 module. Also make sure that you go through the documentation before you make any changes to your script. So I'll see you in the next chapter. So let's look at another way of creating instances. So in this particular EC2 module, I have added two extra parameters, that is the count tag and the exact count. Now the count tag has to point to one of the instance tags that you've created. So in this particular example, I just created one instance tag called foo. So I'll be adding that. And the other parameter is the exact count. So based on the value within exact count, those many number of instances will be created. So for example, if I make this as 2, then there would be 2 instances created. So if I keep changing the values, let's suppose I make it from 2 to 3, then there would be one extra instance created. And similarly, if I delete one and from 2 I make it to 1, then there'd be one particular instance that gets deleted. So let's run this particular configuration and see what happens. So I'll again call the Ansible playbook command. So again, the module to create an instance has changed. So let's go back and look at our instances. So if I just refresh for the ones that are running, so you can see that there are 2 instances that got created. So let me just filter it out just for the ones that are running. So you can see that there are 2 instances. So now let's run this again and let's see what happens. So if I run this again, it should not do anything. Even this particular task, that is creating an instance, should also just pass through without any change. So that's exactly what has happened. So what I'll do next is I will just change this exact count to, I'll just make this as 1 and let's run this command again. So again, you can see that the module to create an instance has changed. So let's go back to our instances. So let's again refresh it just for the ones that are running. So you can see that one of the instances has been removed. So this is how you can use your exact count with your instance tags and your count tags to create just the number of instances that you want. So I hope this was a useful lecture. I'll see you soon. In this particular section, we'll see how we can create a VPC. So whenever you're designing a system, it's always better to have it designed diagrammatically before you actually implement it. So that's precisely what we're going to do. So what we need to create is we need to create a VPC.
And to create the VPC, the module that you'll be using will be the EC2 underscore VPC underscore net. And the CIDR block that we need to give is basically 10.0.0/16. So once we've created this VPC, the next thing we need to do is we need to create a internet gateway, and this internet gateway has to be connected to the VPC. So this is the second resource that we'll create. And again, the module that we'll use to create this internet gateway is the EC2 underscore VPC underscore IGW. So once we've created the VPC and the internet gateway, the third thing we are going to create is the subnet. So we'll be creating two subnets. And for creating the subnet, we'll use the third module, that is the EC2 underscore VPC underscore subnet. And we'll be giving the corresponding CIDR blocks for each particular subnet. And after we've created the subnet, we'll be creating a NACL, that is a NACL. Now, whenever we create a VPC, there is always a default NACL that gets created. However, we'll not be using that. We'll be creating our own NACL, that is NACL, using the EC2 underscore VPC underscore NACL. And we'll be connecting both the subnets that we have created with that particular NACL. And we'll be also adding rules to this particular NACL, that is inbound as well as outbound rules. So once we've created the NACL, then what we'll create is basically the route table. And this particular route table will again be connected to the subnets. Now, there is also a default route table that gets created when we create a VPC. We'll not be using that. We'll be creating our own route table. So we'll be creating our own NACL and route table, and we'll not be using the default that is created when a VPC is created. And once we've created this route table, all outbound traffic that has to go to the internet will go via the internet gateway. So this route table will also be connected to the IGW. So this is how the infrastructure looks like. It's a very basic implementation. So let's look at the Ansible code to implement the same. So this is the code that we'll be using to create the VPC. So I have declared a set of variables that includes the title for the VPC name, the internet gateway name, the subnet name, the route table name, the ACL name, and the CIDR block ranges. So I will also be creating this in the zone US East 1A, and the region would be US East, and the state would be present. So the advantage of declaring these variables here is that you can just set it once and you can use the variable again and again. You don't need to create the same text again and again. And the state here is also present. So we'll be creating this particular resource. So that's one thing to remember. Whenever the state is present, that means a particular resource is being created. So let's look at the task. That is the most important thing that you need to look at. So again, the first thing that we'll be using is the EC2 underscore VPC underscore net module. Again, this is a AWS module and not a community model. So that's something you should remember. So some of the important parameters that you need to add for this module includes the name, the CIDR block, the region, and the state. So the state is again present. So you can go through the documentation and see which are the mandatory fields and which are the ones that are optional. So once you've created this particular VPC, you can store the output of this particular VPC in a register called EC2 underscore VPC underscore net underscore result. And you can use this particular register to get the ID for the particular VPC that you've created. And that is precisely what we'll be using in our next particular module. So the next module that we'll create, so this is based on the architecture that I had shown you previously, is the internet gateway. So this internet gateway has to point to the VPC ID. So this VPC ID we will get from the register that we've created in the task above. So again, the other parameters that you need to create the internet gateway includes the region and the state. So once we've created the internet gateway, the third thing we need to create is basically two subnets. So we've created subnet 1 and subnet 2. And some of the important parameters that you need to create the subnet includes the VPC ID, the region, the zone. So the zone is basically the availability zone that we had configured in the variable section, the state, and the CIDR. So I had explicitly mentioned the CIDR block for both the subnets. So I'll just show that to you again. So both the subnets would have these specific CIDR blocks, that is 10.0.1 and 10.0.2. So once we've created these two particular subnets, so again, I'll be creating one more subnet. So this is subnet 1 and this is subnet 2. So once we've created both the subnets, then we'll be creating our NACL. So this NACL is again connected to the VPC ID. So VPC ID is a constant that is required for all the resources that you create. The region, the state, and you also need to link it to the subnet. So here there's a key called subnet, and within this you also need to mention the subnet IDs. Again, the subnet IDs you will get from this particular register that you had defined. So again, there would be two subnets. There is subnet 1 and subnet 2. And then you also need to define the inbound and the outbound rules for your subnet. The rule that I have defined allows both ingress and egress traffic for TCP port 80. So once I've defined this particular NACL, the last and the final thing I need to define is basically the route table. So again, the route table needs the VPC ID as well as the subnet ID, and along with that the region and the state. And we also create a route, and this route basically defines that any IP address that is not part of the internal VPC IP ID will be sent to the internet gateway. So that's about it. So we've created 6 resources overall. We've created one particular VPC. Within that VPC, we've connected it to the internet gateway. We've created 2 subnets, and we've created our own distinct NACL as well as route table. Always remember that there is always a NACL and a route table that is created when you create a VPC. So this particular NACL and route table is something that we are creating distinctly, and it's not the default NACL and the route table. So once we've created all these, let's create our VPC. So to do that, let's run our playbook, Ansible playbook, and let's create these resources. So you can see overall there were 6 resources that got created. So let's go to our console and let's see if all these resources have been created. So again, the first thing is again the VPC. So the VPC has been created. The next thing we need to do is we need to check the internet gateway. So if I click on the internet gateway, you can see that there is an internet gateway created and it's attached to our VPC that we just created. So okay, the internet gateway has been created. So let's go back to our subnets. So you can see that there are 2 subnets. So let me just search by this particular subnet. So you can see that there are 2 subnets created, and again the range is what we had specified in our configuration. Okay, so the subnet has been created as well. Now again, the final 2 things we need to check is the route table and the NACL. So let's open our route table. So this is the route table that we had created. It's connected to the 2 subnets, and let's open our route table. So the route table should have 2 entries. The one that is default is the one which allows traffic locally based on this particular IP range. And the second one is any other range apart from this particular range should go to the internet gateway. And this is the route that we had created. And this route explicitly makes these 2 subnets publicly accessible. So this is also finished. And finally, let's also check the NACLs. So to check the NACLs, you can go to the security section. You can open NACL here. And this is the NACLs that we had created. So let me just open this. And this also has an inbound and outbound rule. So again, the inbound rule is just allowing TCP traffic of port 80, and it allows an outbound rule of the same as well. So this is how you create all these resources using your Ansible module. So I'll see you in the next chapter.
Hi folks, welcome back. So in this particular chapter, we'll discuss on how we can create an S3 static website. Now to create an S3 static website, we will be using 3 distinct modules. The first module is a module to create the bucket. The second module is to upload a file, that would be the index.html file. And then we'll be using a third module, which would be a community module. So this is the first time that we've used a community module. And this particular module will just convert that particular static website in. And this particular community module will just convert that S3 bucket into a static website. So the first thing we'll do is we'll download the community module. So to do that, you can go back to your Ansible Galaxy page. You can go to the search. You can just type AWS. And then you'll find 2 distinct entries. You'll find Amazon and community. So what you need to do is download the community one. So you can just open this. And you can just copy this particular command and paste it in your Cloud Shell. So I've already done that. Once you've downloaded that, let's create a particular static website. So the first task is to create an S3 bucket. And I've given a name to this particular S3 bucket. So that's stored in this variable here. And then I'm using a policy. So there are two distinct sets of permissions that you need to give to this S3 bucket. The first is the bucket policy, and this bucket policy using this particular lookup is in this particular JSON file called policy.json. So this particular policy.json file gives read access to everybody to this particular bucket. And apart from the bucket policy, I also need to give an access control list. So this access control list, because I need to make this as a public bucket, has to be set to false for all. So these are the two sets of permissions that you need to give. That is, you need to give the bucket policy, and then you need to give the ACL. So both these are given in this particular bucket, and both of them are set to false so that this particular bucket has public access. So once you've given this particular S3 bucket public access and you've created the bucket, the next thing you need to do is you need to upload this particular index.html file. So I have an index.html file in this particular path, and I will just put this particular index.html into this particular bucket that I've just created. And once I've done that, I will just use the community module, and I just need to give the name for that particular bucket again. So this is basically the same name that was specified in the variable. So that's it. These are the only three modules that you need to use. So let's run this particular Ansible configuration and let's create a S3 bucket. But before I run this particular command, let me also show you the policy. And also let's look at the policy.json. So the policy.json allows everybody get access to this particular bucket. And let's also look at the HTML file. So again, it's very simple. It just has a my website homepage, just a few HTML tags. So let's run this particular configuration now. So you can see there are three tasks that were performed. So it created the bucket, it added the index.html, and then it created a static website. So let's go look at our S3 bucket. So this is our S3 bucket page. You can see that this particular bucket was created and it has public access. That means anybody can access this particular bucket. So let's open this. The first thing we'll do is we'll look at the permissions. So let's click on the permissions. So like I said, there were two sets of policies. One is the ACL, so it has all been switched off. And then the second is the bucket policy. So this is the same bucket policy that was there in the JSON, the policy.json file. So it has just been copied here. Okay, so the permissions are set. The next thing we'll see is the object. So there should be an index.html. So you can see that there's an index.html. And the third thing is you can go to the properties. Keep going down. And you can see that the static website is also enabled. So this is what the third module did. So it just enabled this static website hosting. So let's look at whether our URL works. So let's just click on this URL. So you can see that it just outputted the same text that was there in the index.html. So this is how you can use your community module along with your Amazon modules and create a static website. So I hope this was useful. I'll see you soon.
Now let us assume that you have a task that you need to run repeatedly. Now there are two ways to do it. You can keep copying that task again and again with the different parameters, or you could use something called as a loop. So here is a very common example of a loop. So here I have the debug task, and this debug task is just messaging out one particular output. And this particular output is basically the loop. So I have added a new parameter called the loop. And this loop is a list of three values, A, B, and C. When I run this particular task, what it will do is it will run this particular task 3 times and it will print the value of the item, which is the value within this particular list. That is, it will print A, B, and C. So let us try to execute this script and let's see what happens. So you can see that this particular task ran thrice and it outputted all the messages individually, that is message A, message B, and message C. So this is a very important topic because let's assume that you want to create instances and each of these instances are of a different type. Let's say you want to create one T2 micro and you want to create one T3 micro. So instead of creating two separate tasks to do that, you can actually create a loop, and within that loop you can just mention the instance type and that instance type can be put in as the input parameter to that particular task. So I will not do it for the instance. I think that's actually a good assignment for you guys to do. In my next upcoming chapter, what I'll do is I'll create multiple lambdas using the same task. As an assignment, I think it would be a good idea for you guys to just try it out with instances and see if that works. So here is another example. So here I have multiple key value pairs, and these key value pairs are also in a list. So you can access these same values, but here you need to use the item dot name to get these values, and you need to use the item dot age to get these values. So let's run this particular module and let's see what the output looks like. So you can see that the output looks like this. So using the dot variable, you can access all the key value pairs in that list. So let's look at another example. So now let's say you want to use a dictionary rather than using a list. So you can do that as well. So here is my dictionary, and this dictionary has two items, the environment and the application. Now to use this as a list, you need to use one of the Jinja filters that we talked about in our previous lessons. So you need to use the dict to items, and this dict to items will convert this particular dictionary to a list, and everything else remains the same. You again need to use the dot variable to access the values. And here the key would be environment and application, and the value would be dev and payment. So let's run this particular application as well. So this is how you can use your dictionary in a loop. So in the next chapter, we'll create lambdas using these loops. So I'll see you there. So in this particular chapter, our main intention is to create lambdas using loops. So we will just create one task, and using that one task, we will create two lambdas. And apart from the lambdas, the other thing that we will create is a role, and that role we will assign to those particular lambdas that we have created. So the important thing here is that we would be using two modules, and both of them are community based modules. So it's important for you to understand that these community modules are actually more useful than the Amazon provided, because there is more variety and you can do more with those. So let's see how the code looks like. So let's look at a piece of code. So we are creating two tasks. The first task is to create the role, and the second task is to create the lambda and assign that role that we've created in the previous task to that particular lambda. And this lambda module will also be using loops. So let's look at our first particular task. So the first task is to create a role, and we are using a community module to do that. Then we also need to specify two things, the policies as well as the assume role policy. So the policy will contain all the permissions that this particular lambda will have. So I'm using the AWS Lambda basic execution role. So this is a managed service or a managed policy, and this has the following permissions. So it gives the Lambda permissions to create a log group, a log stream, and put log events. So this is the bare minimum policy that you need to give a particular Lambda so that it can execute properly. So apart from the policy, we are also giving a particular policy.json file to that particular role. So this particular policy.json will give access for Lambda to use this particular role. So I will show you how this policy.json looks like, and I'll also show you the final output once everything is done. So let's just look into the policy.json file. So this policy.json will let Lambda have an assume role permission for that particular role that we've created. So that's it for the role. Now let's look at how the Lambda loop works. So this is my second module, which is also a community module. You can either write the last part of your module, or you can give the entire path as well. It's up to your convenience. So I've given a name, a zip, a runtime, and the handler name. And this I have given within the loop itself. So the loop contains the name, which is specified over here. The zip, so the zip is basically a zipped file that contains my code. And then it has also the node, which is the runtime, and then the handler to that particular code. So this particular handler should exist within this particular zip file. I've also mentioned the role. So this particular role is the same role that we've created in our previous task. That is about it. Also make sure to read the documentation for this particular module. The key values that I have given are just the bare minimum. Now based on your architecture, you might need to use some other parameters as well here, but this is the bare minimum that you need to make sure that this particular module works. So let's run this particular task. But before doing that, let me show you the contents of this particular zip file. So I've unzipped my particular zip file, and this is the folder that I get. So let's open this particular folder. So I'll just copy this. So it contains an index.js and the package.json. So this index.js will contain the handler code. So if I open this particular index.js, you can see that it contains the handler here. So it is important that this handler's implementation should be within this particular zip folder. So that's about it. Now let's create all these resources that we've just configured. So again, I just need to run the Ansible playbook command. Okay, so the configuration has run. So again, let's go back to our functions. So you can see that there are two functions created. So let's just open one of these functions. So you can see this is the same code that was there in the zip file. And the other important thing to check is the permissions. So let's go to configuration. And within that, let's open permission. And this is the new role that we had created. So this was the new role that we had created. So let's just open this particular role. So if you open the role, you'll see that it has the policy that we had defined. And if you open the trust relationship, and if you go down, you can see that the trust identity provider is the lambda.amazon.aws.com. So this was configured because of the policy.json file that we had applied. So that is it. That is how you can create lambdas using loop. So I hope this was a useful lecture. I will see you in the next.
So now let's talk about inventory. So whenever you create an EC2 machine in AWS through Ansible, you have the opportunity to have an inventory set of all the EC2 machines that you have created and group them together based on how you would want to have programs or applications downloaded to them. So there are two ways in which you can create inventory files. You can either create a static inventory file. So in a static inventory file, you have to manage the inventory file on your own, and you will have to add the IP address of the EC2 machine whenever you create it. Whereas if you're using a dynamic inventory file, all that is done by the plugin itself. So you do not have to worry about manually adding EC2 instances into your inventory file. So let's start by talking about the static inventory file. And once we're done with that, we'll also deal with how the dynamic inventory file works. So let's start. Okay, so let's start by creating a static inventory file. So the first thing you need to do is you need to create a key pair. So to do that, you can go to your EC2 dashboard, and underneath network and security, you can click on key pairs and you can create a key pair. So I've already created a key pair called AWS underscore Ansible, and I'll be using this particular key pair to create the instance and SSH into it. So once I've created the key pair, I'll get a private key. So this private key I've already uploaded to my Cloud Shell. So this is the private key that I have. So the first thing we'll do is we'll create our instances. So let's go back to the old script that we had created. So that is the create instance.yaml file. So let me just open this file. So here the only thing I've done is I've also added the key pair. So the key name that I've added is AWS underscore Ansible. And apart from that, I have created two instances. So if I need to log into this machine, I need to use it using the AWS underscore Ansible key pair. And everything else is the same. So the first thing we'll do is we'll create this particular instance. Okay, so I've created two instances using the script. So the next thing I need to do is I need to create an inventory file. So to do that, I'll go back to my Cloud Shell. I'll create a file called inventory. And here I just need to paste the IP4 or the DNS name for this particular instances. So I'll go back to my instance and I'll just copy this particular IP4 DNS. I'll paste it here. And again for the second machine as well. So I go back to my instances. I'll copy this as well. And that's about it. So once you've created your inventory file, you would want to list all the entries in your inventory file. So to do that, you can run the Ansible inventory. Here you need to specify the name of your inventory file. So the name of my inventory file is also inventory. And then you can either specify it as a list or as a graph. So let me first specify it as a list. So you can see that I have two ungrouped EC2 instances here. So you can also do the same using the graph. Okay, so you get the same output, but this is as a graph. So the next thing that I would want to do is I want to group these two IP addresses as well. So to do that, let me just go back to my inventory file. And all I need to do is I need to group these. So to group your instances, you can either group based on how your machines are grouped in your architecture. So let's assume that one of these machines is basically the web server. So I can group this as a web server, and the other machine is basically a database. So what I've done here is I have grouped machines based on what it actually does or what activity it performs. So I have assumed that this particular EC2 machine is a web server and this particular EC2 machine is a database server. So let's exit this and let's run the same command that we ran previously. So now you can see that it is grouped based on a database and as a web server, and all of them are grouped as all. So the next important command that we'll run is basically the ping command. So let's assume that you want to ping all the instances. To do that, I will be using the Ansible ping module. So the first thing I need to do is I need to ping all. So this is basically all the instances, and I need to mention the inventory file. So the inventory file is inventory. And I also need to mention the private key for those particular instances. So the private key is basically the PEM file that I had downloaded. So the private key is in my home directory. And then the module that I want to run. So the module is the basic ping command. So this should work. So let's trigger this particular command. Okay, so one thing that I have not mentioned is which particular user. So the user that I need to mention is basically the user that would log into this machine. So the user is EC2 hyphen user. So now you can see that the ping works. So this particular user can also be specified in the inventory file. I haven't mentioned it, but I'll send you a documentation to the inventory file, and you can go through them and see all the variables that can be set there. So now let's assume that you just want to ping one of these instances. So let's assume that you want to ping just the database. So here, instead of all, you can just do a DB. So here you can see that it has just pinged that particular database instance. And let's assume that you want to run any other command. Let's say that you want to run the lslt command. So I'll do a command module. And here I need to add the arguments for this particular command. So the argument here would be, let me do an lslt here. So this will display all the files and folders in the home directory of this particular database machine. So let's run this particular command. So you can see that these are all the files and folders within this particular EC2 machine. So that's it for this particular lecture. In my next lecture, I'll show you how you can create a dynamic inventory file. So I'll see you there.
Okay, so in our previous chapter, we had created a static inventory file and grouped it based on whether it's a web server or a DB. So the web server was grouped as web and the DB was grouped as DB. So in this particular chapter, we'll just target the web server, and what we'll do is we'll install Apache on those web server instances. So to do that, again, if you go look at the code, the host here instead of localhost would be the group ID name. So the group would be web, and the user that I need to mention is again the EC2 user. And here there's a new variable that I have included, and that is become. And what this does is that it enables sudo access. And the task here is again to install Apache. And the module that I would be using is the YAM module. And I'll be installing HTTPD. So that's about it. Let's run this particular playbook. So here I need to mention the inventory as well as the private key. And here this is the name of my playbook. So let's run this particular command. So you can see that Apache has been installed in this particular machine. So let's go and check whether it has been installed. So again, I go back to my instance. So the instance is 224. Once you've logged into the machine, you can just run the system start HTTP service and let's run this. And once you run this, you can go back to your machine. You can just copy this address and you should be able to see the test Apache web page. And you can see that this has worked. Now this particular step can be done in Ansible playbook as well. So that would be a good assignment for you. So once you've created your Apache server within the playbook itself, just run this particular command so that you don't have to manually do it. And you should directly be able to see this web page without having to manually start the service. So I'll see you in the next chapter. So now let's talk about the dynamic inventory file. So the problem with the static inventory file is anytime a new instance is created, it has to be manually added to the static inventory file. So to overcome that obstacle, we have the dynamic inventory file. And AWS provides a plugin called AWS_EC2.YAML to do that. So let's go back to our galaxy.ansible.com. And here, if I search for the Amazon provided modules and plugins, you can go to your contact. And here, let's just search for the plugin. So we'll be using the AWS_EC2 plugin. So now what we need to do is we need to create an inventory file based on that particular plugin. So I already have created a particular inventory file. So let me just show you the contents of that. So this particular inventory file does not have any instances hard-coded. What it has instead is basically a key value pair, and the key value pairs include the plugin. So this plugin is basically the plugin that we just saw. And apart from that, it has a region key, and this particular region key has a value of US East 1. So this particular inventory will only search for instances within this particular region. And then there is the keyed group. So this particular inventory file will group instances based on the tags as well as the instance type. So the tags that I had given while creating the instances was web server, and it will basically group based on that particular tag. And also it will group based on the instance type of each particular machine. So the instance type that I had given was T2 micro. So let's run this particular inventory file. Again, the syntax to run the inventory file is the same as that for the static inventory file. So this is the syntax to run the inventory file. Again, I just need to provide the path for the inventory file, that is AWS EC2 YAML. And you can either display your inventory as a graph or as a list. So let's start by displaying it as a graph. So you can see that it has been grouped based on the tag. So this was the tag. The web server was the tag for that particular instance, and T2 micro. So we have got two instances, both of them are T2 micro. So they've all been grouped together. So now that we've displayed based on the graph, let's also display based on the list. So this also gives a similar value. Now let's do a ping like we had done in our previous chapter. Again, to do a ping, we'll basically run the same command. So it'll be Ansible all. So all would mean that I'm trying to ping both the instances, and I need to give the path for my inventory file, that is AWS_EC2.YAML. Then the path to my private key. Again, this is in home hyphen. And then I need to give the module that I need to run, which is basically the ping module. And I also need to specify the user. Here the user is EC2 hyphen user. And you can see that the ping was successful. Let's also run another command. So let's run the lslt command. So the module for that is command. The argument is, and again I need to mention the user is EC2 hype. So this is So basically it has nothing in its home directory. So let's also try to display the hidden directories. So you can see all the directories or folders are basically hidden. So now this time, instead of running for all, let's run for this particular tag. So this command remains the same. The only thing I need to do is I just need to replace all with tag web server. So what I'll do is I'll just replace the all. And now this particular tag web server, all the instances within this particular tag web server will be pinged, which is basically again these two instances. It's basically the same as all, but let's try and see if this works. So you can see that this works as well. So let's also do a ping command for that. So instead of all, I'll just replace it with tag web server. So you can see that this works as well. So this is how your dynamic inventory file works. I hope this was useful. I'll see you soon.
Whenever you run your inventory file, you get a certain list of information about your instances. So let's run this particular inventory file. So you can see that you got a certain set of information about each of the instances, and these information values you can access through hostwares. Now let's assume that you want to get this information in your playbook. So how do you do that? You can use something called as magic variables that Ansible provides. So using those magic variables, you can retrieve information about the instances that are available in your inventory files. So let's use some of these magic variables. So I've created a very basic playbook called magic variable. So here what I'll do is I'll just message out all the magic variable information. So if I go back to the Ansible page, these are some of the magic variables available for your inventory file. So let's use the hostwares and let's see what the output is. I will just paste the hostwares. And when I'm running this particular inventory file, I have to mention the inventory as well. So this inventory, so the information in this inventory we can get in this particular playbook using these magic variables. So hostwares is one of the magic variables. Let's see what the output looks like. So you can see that hostwares was able to retrieve certain set of information about each of these instances. So that's about it. These magic variables will come in handy in our later section. So this was just a heads up. So you should always remember that using these magic variables, you can access information from your inventory file. So I will see you in the next chapter. So in our previous chapter, we had talked about inventory. Now, the problem with inventory is that it can only give you a certain set of information. For example, what type of instance it is, for example, if it's T2 micro, or what is the IP address of the particular instance. Now, if you want to go in depth and know certain things about the instance that you could only get if you log into that machine, then you need to use something called as gather facts. Now, using gather facts, you can get a lot more information about that particular instance. For example, what kind of distribution it is using, what is the CPU of that particular instance, how many processors are there, what is the memory. Now, those kind of information you cannot get using the inventory file. So now let's look at an example of gather facts. So now let's look at a playbook. So here this particular playbook has gather facts set as true. So the default is true as well. And here the host I have mentioned is not all but one certain instance. That is the instance that has a group name of tag named Red Hat. And I've also mentioned the user. And also another parameter that I would want to introduce to you guys is become equal to true. So this lets this particular playbook have pseudo access to that particular instance. And that's about it. The only thing I'm going to display out is the Ansible underscore facts variable. So this particular variable will give you all the information about that particular machine. So let's run this particular machine. Now, since we need to log into that machine, we also need to provide the secret private key for that particular instance. So I'll be doing that as well. So here is how I will run that particular playbook. I will give the inventory name and I also need to mention the private key. So here is the part to that particular private key. So let's run this particular instance. So here the set of information that you would get would be more profound and more in depth. So it will give you a certain set of information that you will not find in the inventory file. For example, the blocks available in each mount, and also the kind of distribution you're using, the amount of free memory that it has. So this kind of information, if you want to access, then you need to use gather facts to get that. So that's it for gather facts. It's an important concept to understand. So just remember, anytime you want to get more in-depth information about an instance, then you need to do gather facts equal to true. And that will give you a certain set of information that is not available in the inventory file. So I will see you in the next chapter. So in this particular chapter, we'll talk about conditionals, but apart from conditionals, we'll also include certain learnings that we have done in our previous section. So this is how our architecture will look like. I have my local host, that is the Cloud Shell, and this local host has Ansible installed in it. The first thing I'll do is I will create a playbook called site.yaml, and this sitebook YAML will have links to two distinct separate playbooks called create.yaml and install.yaml. So the job of the create.yaml is to create instances, and the job of the instance.yaml is to install applications in those instances that we've created. So we will run this particular site.yaml, and the first thing it will do is it will create instances. So once your create.yaml runs, it will create two instances, and these instances will be named as Red Hat and Ubuntu, and they will have two distinct distributions. That is, one will have Red Hat and the other one will have Ubuntu. So once you have deployed your instances, or should I say, once you have created your instances, the next thing that you would want to do is you want to update the inventory file. So we have a dynamic inventory file. So initially the inventory file would be null, but we will use a module called meta, and this meta has a key called refresh underscore inventory, and this refresh underscore inventory will refresh the inventory file that we have, and it will have two instances shown in it. So once you refresh your inventory file, you'll have a fresh inventory file that will contain information about those two instances that we've created, that is the Red Hat and the Ubuntu one. And after we've done that, the next thing that we'll do is we'll install the web server using the install.yaml. And this install.yaml will create SSH connections to both the hosts. So once your SSH connection is formed, it will run this particular script once on both Red Hat and on Ubuntu. Now the problem here is that Red Hat has a user called EC2 user and Ubuntu has a user called Ubuntu. So now what we need to do is based on the value of the inventory file. So the inventory file has got a tag based on whether it's a Red Hat or an Ubuntu instance. So here, based on the value of the tag, you can either define the user to be EC2 user or Ubuntu. So once you got your username, the next thing you need to worry about is installing Apache. So to install Apache in Red Hat, you need to call the yum plugin. And to install Apache in Ubuntu, you need to call the apt plugin. So how do you know which particular plugin to call? So that's where your conditional comes in. So here what we are using is we are using the gather fact variable called Ansible underscore fact, and we are using one of the fields within that Ansible facts called distribution. Now, if the value of the distribution is Red Hat, then we'll install yum because we know that currently we are on the Red Hat distribution. And if the Ansible fact returns Ubuntu, that means we know that we are on the Ubuntu distribution and we can install the apt module. So that's how this works. So let's run this piece of code. So now let's look at a piece of code. The first code that I would like to show you is the site.yaml file. So the site.yaml file just calls these two other playbooks that we've created, that is the create.yaml and the install.yaml. And using this particular syntax, we can call this playbook. So you should always remember this dash include is used to call playbooks directly. So if you want to have another playbook within site.yaml, you can just use the dash include to call that particular playbook. So once your create.yaml runs, then it will run the install.yaml. So it doesn't happen simultaneously, it happens one after the other. So let's call our create.yaml. So our create.yaml consists of three tasks. So the first task is to create the instance. The second task is to refresh the inventory after the instance has been created. And the third task is to pause for a minute so that the inventory has been refreshed in time for the next particular playbook to run. So the first particular task that you see here, that is the include underscore task. So this particular module will call this YAML, and this YAML contains the syntax to create the instance. And this YAML will run twice based on this particular loop. So this loop will first create the Red Hat instance, and then it will create the Ubuntu instance. And after these instances have been created, using this meta module, we can just refresh the inventory. So this is an important module to remember. And after that, we will just pause this particular playbook for a minute. Now let's call the create instance.yaml. So as you can see that this create instance is not a playbook, but it's just one particular task. And this task is just to create the EC2 instance, and it will pick up these variables from the loop. So the EMI and the name is basically set for the tags and the image. And after your instance has been created, then we'll call the install.yaml file. So let's look at the code for the install.yaml file. This particular install.yaml file will run once on both your Ubuntu and on your Red Hat instance. So whenever it's running on the Red Hat instance, it will check for the inventory file and see what that particular tag is for that particular instance. And if it is Red Hat, then it will set the user to EC2 user, else it will set it to Ubuntu. So once you have logged in, the first thing that it will do is it will try to install the Apache web server. Now it will do that based on a condition. So let's assume that you are currently in the Red Hat system. Then it will check for this particular condition. So it will check whether your gather fact distribution is Red Hat. So if it is Red Hat, then it will run this piece of code and it will skip this particular piece of code. And after it exits from Red Hat and it enters the Ubuntu instance, it will do the same thing again. It will again check for the distribution. If the distribution is Red Hat, then it will skip this part and it will just run this particular part. So that is how the conditions work. So the conditions will work only if this particular condition is satisfied. So now let's run this distribution and let's see how the output looks like. So I'll run the Ansible playbook site.yaml, and here I need to give the distribution as well as the private key. And the private key again is in my home directory. Okay, so the output is done. And if you look at the yum and the apt task, you can see that it did not change for both, but it just skipped for one of the instances and it changed for the other one. So this is how you can check for your conditional. So your condition skipped for this. So this is basically the Ubuntu task and this is the Red Hat. So it just worked for the Red Hat. And your APT again, it skipped the Red Hat and it just changed for your Ubuntu. It just changed for your Ubuntu instance. So that is how you can use your conditional. So I hope this was a useful lecture. I will see you in the next. So let's talk about roles. So why do we need roles? So let's assume that you've created a playbook and you want to distribute that playbook among different users who are sitting in different offices in your organization. Now, of course, you could manually give those playbooks to each one of them individually, but that's actually a cumbersome task. So you could rather use something called as Ansible roles instead. So let's look at what Ansible roles is. So Ansible roles lets you automatically load variables, tasks, and handlers and other Ansible artifacts based on a certain file structure. And once you group them together, you can actually reuse them and share them with other users as well. So let's suppose that you've created this particular playbook. So this particular playbook consists of variables and tasks. Now, what you need to do is you need to regroup them based on a certain structure. And this is how the structure of the roles look like. So what we will do is we will copy all the tasks from a certain playbook that we've created, and we'll copy the tasks to the task folder, and we'll copy the variables to the variable code folder, and then we'll upload this role so that using the role you can do the same task instead of using the playbook directly. So let's proceed and let's see how this is done. Okay, so in this particular chapter, we'll create a role, and this particular role will be used to create a network. So the first thing that we need to do is we need to create a scaffolding for a particular role. So to do that, you can run this particular command, Ansible command. So it's called Ansible Galaxy init, and then you need to give the name of your particular role. So this is the role that I have specified. So let's create this particular folder. Okay, so finally we've created this scaffolding for our role. So the next thing that we need to do is we need to add code into it. But before that, let's look at the structure of our particular role. So I will just move into this particular folder. And if you see the folder structure, you see that there are folders created. So there's a folder for your defaults, for your files, for your handlers, for your tasks, templates, tests, and variables. So in our particular example, we'll be using the variables and we'll be using the tasks. So what I'll do now is I will make use of a playbook that I had previously used. So I had previously used this particular playbook to create a network. So let me just show you this particular playbook and what I'll do with it. So I'll just copy this and I'll show you this piece of code. And this piece of code contains a set of variables and a set of tasks. So what I will do is I will copy these variables into the variables folder and I'll copy these tasks into the task folder. So let's do that. So I've copied those variables and those tasks. So let me just show it to you. So I'll go back to my variables folder. This main.yaml has basically all the variables that was there in the playbook. And if I go to the task folder, let me do a main as well, main.yaml. And you can see that all the tasks that were there in the playbook I have copied here. So that's the only thing that you need to do. Now what I need to do is I need to upload this into a Git repo. Okay, so after you've created your role, the next thing you need to do is you need to create a repo in your GitHub. So to do that, you can just go to your GitHub and you can create a new repo. So I'll just call this as Ansible AWS role and I will create a repo. And then you just need to run these commands. So I'll do a git init. So again, this is my folder structure where my code exists. I'll just do a git init and I'll just do a git add, a git commit. And then I'll run these commands, the git branch. So let's go back to our repo and let's see whether the code has been uploaded. So you can see that the code is present in my repo. So now what I need to do is I need to go to my galaxy.ansible.com. After you have uploaded your code, the next thing you need to do is you need to go to your galaxy.ansible.com and then you need to log in. So here you can just give your GitHub credentials and sign in. And then you need to go to the add content tab. So this is basically my content and you can just click on your add content here. And you need to import the role from GitHub. So you can just click on this and you can just add the repo that you have just recently created. That was the ansible.aws. That is the ansible underscore aws underscore role. So I'll just copy this and I'll click on OK. And after you've done that, you can see that your code has been imported to your galaxy.ansible.com. So let's just open this particular role. So all that you need to do to use your particular role is just run this particular installation. So I'll just copy this and I'll run it in my Cloud Shell. And you can see that my particular role has been imported. So now all that I need to do is I just need to use this particular role. So to do that, let me just create a very basic playbook and that playbook will just be using the role. So I've created a very basic playbook and this particular playbook will not have any tasks, but it will have this particular role. So this is just the role that we had just imported from our galaxy.ansible.com. So that's all that you need to do. Now let's run this particular playbook. So to run this playbook, we'll run it as we usually do. So it's just Ansible playbook. And the name of this particular playbook is role.yaml. Okay, so the playbook has finished running. So you can see that all the tasks that was present in that particular role has been executed. So we can go back to our VPC and let's just refresh this particular page. So you can see that your VPC has been created. So this is how you use roles, and roles are actually quite important, especially if you're working in large teams where people are working in different geographies. So roles can come in handy, especially if you want to share playbooks and variables. So that's it for this lecture. I'll see you in the next.